Hello everyone, welcome in another important video. And in this video we will learn how to create our first ever machine learning module, and this is going to be our customized machine learning module. So whatever object that you have in your household or nearby you can click photos of those objects and you can train module on that. Okay, so this video is going to be really interesting, especially for those who don't have any prior experience in machine learning and wants to learn machine learning, wants to understand how the things work. So this video is going to be completely informative for them as well. Okay, let me introduce myself. I am a full stack developer. I have 5 years of experience in developing full stack applications in JavaScript. I do not have any experience in machine learning, and that's the interesting thing, because if you don't know anything, you will face some challenges that all beginners will face, and those are the things that I'll share in this video. This video is going to be informative for those who are beginners in a machine learning. Let me set some expectations for you in this video, and I'll also tell you what you can't expect from this video. So first thing that you can expect from this video is to learn how to set up environment to train any machine learning module. Okay, obviously if you have different problem statement, setup could be different, but for computer vision and just basic model training, you can follow these steps. Second thing, you will learn how to create dataset. Third thing, you will learn how to augment the dataset. I'll explain more about augmentation when we will actually reach there. So basically augmentation is the way to increase your dataset. The fourth thing that you will learn from this video is how to actually train your machine learning module and how to test it. Okay, so these are the things that you can expect from this video. It's my job to inform you what you can't expect from this video. So if you are expecting to create any high accuracy machine learning module, this video might not be perfect fit for you, because this will cover all the basic, and we can't expect in a first attempt itself we will be able to create high accuracy machine learning module. The module that I have created also has some flaws. I'll explain that when we will actually reach there. But at the end of the video, you'll be able to create a machine learning module which will be able to detect your objects. Okay, I'm not saying it will give you 100% accuracy, but yeah, you will have machine learning module. Well, I think that's enough for the introduction. Now let's jump into article and we'll start doing the actual things. So first, here I have the first things first, we'll need to set up our environment first. So first basic thing that you'll need to do is you need to install Python environment. I will suggest you to install a specific Python version that I will tell you, or at least a range of versions. You have to install one of the Python version, stable version of Python in between the range that I will tell you, because that version is going to be important when we will actually start working on building installing the libraries. One of the libraries that we will use, if you see in article itself, let me tell you, Ultralytics. So this is the library that we will need to install in order to train our module, and this has a dependency on specific Python version. So if you scroll this documentation over the setup, let me quickly search setup here. Here. So first thing you need to do is you need to install Python, but here I have mentioned you need to install Python version specific in between 3.6 plus, and it has to be lesser than 3.12. Obviously the latest Python version you will see will be greater than 3.12. 3.13, 3.14 is also available, but for this specific project you have to install version which is greater than 3.6 and lesser than 3.12. all right, so this is the first thing you need to do. And how you will do it, just go to pythonorg.com, and here you will see all the different versions. Go to 3.6, I guess. Let's scroll down a little bit. The version that I have personally installed is, let me tell you what is it. Let's see what is it. So let's run python -- version. Okay, so I personally have version 3.10. So let's go and install that itself. So here you will see all the Python versions here, and you can use any one of this file. I'll suggest you to use installer, because that's the simplest way to install Python in your system, and it also helps you with setting up an environment variable which you often requires. Otherwise you might have to do it manually. So just download this installer file and follow the installation steps, and you will have Python version installed. I'll show you how to do that, so that there will be no confusion in your end. So this is how the first UI will look like. Since I have Python already installed, it's asking me to upgrade that version. If you do not have any Python installed, it will ask you to install that. Alright, so you can just follow the steps and you will have Python installed. So once you have Python installed in your machine, next step is to install Visual Studio build tools. I know this is gonna be confusing for you, because since we are not working on C++, so it's quite obvious that you will ask, why do we need dependency, why do we need to install Visual Studio tools? But that's because when we will work on creating and building our modules, it seems that there are some dependencies you need to install, especially the Ultralytics library. This requires some dependencies or some DLL files that this installation has. That's why you need to compulsory install Visual Studio C++ build tools, and process is quite simple. You just have to follow this link in a I'll put this link in the description. You will land on this page where you will need to install this build tools, and let me tell you, this build tools requires at least 8 to 10 gigabyte of space of your machine. So keep some space empty. Just install this like this, click on continue, and just wait until it gets downloaded, and then you will have this interface. Just click on modify if you don't have it. Then you'll have to install some dependencies, as I mentioned. So you need to install desktop development C++ libraries, and maybe it's not a dependency, maybe this is not required, but still let's not take any chance. Since this is our first project, we don't want to get frustrated with the dependencies. So install this dependency as well, which is Windows Application Development Build Tools, and then click on install button. It will install all the required stuff, and then at the end you'll just once it is installed, just close it. Okay, so with this way you will have the entire required setup ready. You need to install YOLO, but I'll tell you how to do that when we will actually jump into the code. Next thing that you will need to do is just create a fresh folder, give it a name, let's say first ML project. But before we actually start coding, we need to collect our data. Okay, and data collection is one of the crucial process. Okay, so let's imagine the scenario where you want to create a module to detect, let's say, your any personal object. Let's say I want to detect my cell phone, but I will recommend you to choose those objects which are not common, because machine learning module that we're going to be using, which is a YOLO, it's smart enough and it has a lot of pre-built classes. So don't use any common class. I will recommend you to use something which is uncommon. Let's say in my case it was a phone case. Maybe you can go with the phone case itself, or you can use your headphones, you can use your mic, you can use your helmet, anything that is uncommon and not listed in the default train module. Okay, so I personally choose to train my machine learning module to detect my phone cases. So what I did is I just collected images of my phone case, and here is the process to collect data. So here's the first process that I have mentioned, is to collect data. In this data collection process, you'll have to click images of your object that you want to detect in different angles. So For example, this is my phone and I want to detect this phone, so I'll just have to click images of this phone in a different angles, so that I can feed that data to my machine learning module to learn from the data. Okay, so when I started, I didn't know that it requires a lot of images, and if you don't click multiple images, your machine learning module will not be smart enough to detect your object. So initially I took only 10 images, but I will recommend, if you are clicking images now, just click more images. At least 100 images are required, so that then you can expect good performance from your machine learning module. If you don't want to collect data from yourself, then you can download that data. One of the way to download dataset is a Kaggle, one of the most popular website from which you can expect machine learning codes, machine learning datasets. So here is the link that I have provided in the article. Just follow this and you can download any dataset you want, but make sure that you shouldn't download like huge dataset, otherwise you will face it will take a lot of time to train that data and to label that data. So this dataset is 9 gigabytes, so don't download dataset which is a very huge dataset. I will recommend you to use dataset which is quite smaller than 50 MB. Then the training will get complete within half an hour or maybe 1 hour, depends on your machine performance. Just to get started, I will recommend you to use smaller dataset, or maybe the easiest way to click your own images. Okay, I expect at this stage you will have multiple images, at least 40-50 images of your object that you want to detect. Okay, so once you have multiple images, now you have to label that data. The way things works is, you will have a data set. Okay, you will split that data set in a training data set and a validation data set, or maybe you can say testing data set. So let's say you have 10 images, you have to split that data set into 70-30 ratio. Okay, so in this case, since I have 10 images, I'll split 7 images as my training data set and 3 images as my validation data set, or you can say testing data set. All right, so this is really important. You can keep 70-30 ratio, maybe you can go with 80-20, but don't go 90-10 or maybe 50-50. Don't go with that. Try to use your data set as much as possible for the training purpose, and also keep some buffer to test it. Okay, so just divide your data set. Now the thing is, you have to label your data. So whatever the data that you have, all 10 images in my case, I'll have to label it. Okay, so labeling is the process in which we select object that we want to detect and we label that data. Okay, let's see how to do that. So to label data, I realized when I did Google research that there are multiple tools available. Among this, I think image or let's say label IMG is one of the tool that is open source. I use this personally, but if you have any better recommendation, please comment down below so that people can use that tool. But this is one of the simplest tool, I guess. You just have to go here and go to releases, I guess. Releases in here, go to binary, and just download this Windows v18 or whatever the version that you will see here. Okay, just download this zip file and extract this zip file. So once you extracted it, you will have this folder. Okay, under this you will see this label img executable. Just click on it. You will see some command line, and then you will have interface like this. So this is a tool that we will use to label our data. Okay, I'll tell you what is labeling and why it is important, but before that, let's start the process so that it will be easy to understand when we will actually do the things. So let's open the directory, and here I expect whatever the images that you have clicked, you have already split it in training and test data set. So I'll go ahead and I'll just use the same data set that I have here. Let me go to my ML folder. Well, this is well, this is a code that I have already completed. So I'll just use the same data set that I have. So if you go to datasets, let me quickly copy this. I'll paste my dataset in here. Wait, I'll have to create new folder before I create images and label folder. This is because the syntax, maybe libraries that we are going to be using have a specific folder structure, so they expect that folder structure. So let's create one folder with the name data sets, and then let's put all images and labels under that. I'll delete this. Okay, now I'll explain you the folder structure. Here you will create two more folders with name train and value. Same with labels, you will create two more. Let me delete this cache. You will create two more folders, train and validate. This val is validate. So the ratio that I told you to split your data set, so this train data set will have, let's go to images. Okay, here this train folder will have 70% of your images, and this validate folder will have 30% of your entire data set. Okay, so here I have already created my data set. You can see I have around 1 2 3 I have around 7 images in here. And then if you check my validate folder, I'll have 2 images. Okay, I'll recommend you to have more images as much as possible, because that will impact your accuracy if you use smaller data set. But I'll tell you what's the workaround for this as well. But for now, let's just go with what we have. Okay, now let's open our train dataset folder, which is inside I think documentation, first ML project. Then let's go inside images, train. Let's select this folder. Now you will see we have all the images that we have clicked. We have all the images. So let's try to label this one by one. Yeah, it will save your label, but it will save label in the given directory, and I want to save this somewhere else. Let's go to first ML project, and under this let's create new directory. Let's say labels, and we will store all our labels in this directory. Save this, and now let's select our area where we have actual object, and I'll name it as a mobile front. If you don't have any class that you want to if you don't have any label that you want to assign, just type whatever you want and click on OK. Okay, in my case it's already there, so I'll just use mobile cover front. Okay, click on OK. This label is completed. Save this, and now you will observe one thing in our project labels folder that we have created. You will see there is one text file got created. Oh wait, this is XML file. So this is because this is supported to Pascal VOC, and since we are going to be using YOLO module, so we'll have to label it as per compatible to YOLO. So we'll have to select this. Let me delete this. I'll just remove whatever we have inside it, so it will avoid some confusion. Okay, so now let's select the area where we have our actual object like this, and then label your object. So if you don't have a label that you want to give to your object in here in this list, just type something or whatever you want to give a label to this selected area, and then click on OK. Since I have already labeled listed in here, so this is my mobile front, so I'll just select it front and click on OK. So now this label is completed. We'll have to save this, and now if you observe your labels folder, you will see two files. One is classes file, in which we'll have all the classes in the text format. So this is mobile cover front and this is mobile cover back. If we create new label, it will be there whenever we will save it. And here in this text file you will see different coordinates, or you can say different position location. the point that we have selected here might be 0.49, and point we have selected in here might be 0.46 or something like that. Okay, so these are the these are the points that we have selected. Okay, now, and the first thing that you will see here is the class name index. Okay, so here we have two classes, mobile cover front and mobile cover back. Since we label this object as a mobile cover front, this is a first index of our label. That's why we have mentioned 0 here, or maybe that's why tool automatically mentions 0 in here. Okay, let's try to label something which is mobile cover back. Okay, let's select the area first, and let's label it, let's say, mobile cover back. Okay, let's save this. Now you will see, since this mobile cover back is a second class we have here, which is in our class.txt file, that's why we will always mention 1 in here, because array index always start with 0. So this will be 0, this will be 1, and if we have multiple labels, that will be go on like 1 2 3 4 5 6. Okay, so let's try to open our second file, but that will get generated only when we will save it. Okay, so now we have second file. Now you see here, this is 1. Okay, this is because our mobile cover back class is index second. That means if we start our array with 0, we'll have mobile cover back class name at first index. Okay, so let's complete our all the data set like this. All right, so with this way, we'll have all the images in a train data set labeled. So you see here all the txt files are there. So just copy this txt files and go to your labels folder, but that should be, wait a minute, let me copy all the files from here. Go to your datasets folder. Under the labels folder, you will have train folder, and just paste all the files in here. Okay, now one thing you will notice, let me duplicate this if it is possible. Yeah, let's duplicate this. Let me go to datasets folder, images, and train. Here you will notice the file name that you will give to your image will also be applicable for the text file that you will generate. So the way these things will work is, a machine learning module will compare, machine learning module will search labels for this images in this folder, which is in the labels folder, and it will search it by name. Okay, it will just search a file name with txt format, and it will pick all the labels from that file. So this file name is really important. That's what I want to mention in here. Okay, so once you have all the trained data set, just go for validation data set as well. Follow the same steps. Go to your label, go to label img tool, open the directory, which is val in this case, and this should have 2 images. Just select area for that, and make sure YOLO is selected in here, and just select the area. Do the same process, allocate the class and stuff. And for this as well, you will have txt files, and once you have a txt file for these 2 images, copy those txt files and go to labels folder, val, and paste those 2 files in here. Okay, now I'm considering you will have data set which is already labeled. Once you have data ready, now you can just write an algorithm and train your data set. Okay, one thing you have to do is go to your root folder where we have labels in here, copy this classes file, and make sure that this classes file is in your project directory, which is in here. And now I can delete this labels folder, because I already have labels folder in the datasets directory. Okay, well, this is important. Now we have dataset ready. We can go for training our module. So let's install some dependencies first. So here, if you launch, now you can close your labeling tool, go to cmd, clear everything, and change your directory to your folder in which you have your code. Let me copy this path. Let's go here. Right. Okay, so now we are in the directory, and now we need to install some dependencies. So let's install first dependency. Let's go to article. It's gonna be an ultralytics. So command for that is I think, let's search python install. I don't think I have mentioned this in article. I'll mention it, but let's search python install ultralytics. Yeah. Okay, this one. Okay, so this is a library that is gonna help us to train our module. If you want to learn more about this, you can refer this documentation. But let's go ahead with installation. So installation step, I think, is quite simple. I don't think we have any command in here. Yeah, we have to follow this command. Go here and just write pip install analytics, and this will install all the required dependencies. And if there is any error while installing this dependency, it will throw the errors. Okay, most likely if it throws errors while installing, it might be related to c++ dll dependencies. So you just have to make sure that you have installed Visual Studio, Microsoft C++ build tools. If it is installed in your machine, then you can easily install Ultralytics library. All right, since I already have this Ultralytic library installed, so it's not gonna start the installation process all over again. It will take some time to install, roughly around 2 to 3 minutes, if all the setup is ready. And also make sure that you have the perfect version of Python, because that is a dependency. If you don't keep the same version, which I have made, if you don't keep the Python version in between the range that I have already mentioned in the beginning of the video, then you will go you will face some errors while installing it. Okay, so your Python version has to be greater than 3.6 and has to be lesser than 3.12 if you're going to be using this library. Okay, at least I face the issues, that's why I'm telling you. Okay. Okay, cool. Now I'm considering you already have. Now let's start our process to train our module. I have already mentioned that you have to keep 70-30 ratio. 70% is going to be your training data set, and 30% is going to be your validation data set. You can call it as a test data set, which you will put in this folder, right? So since we already have this folder ready, under this images, train images, we will keep 70% of our images. In my case, it's going to be a 7 images. And in images val folder, I'll put 3 images or 2 images, whatever the left, whatever the images are left, I'll put them in this validation folder. Same with the label dataset. All the images that you have put under this train folder, is label you will have to put in this label train folder. And then whatever the images you will have in the image val folder, you will have to put its label under this folder. Okay, so these are pretty simple, and you have to create classes.txt file, and in the root folder, so which that also we have completed. So you can see this is a folder structure right now, where you can see this folder structure. This is a datasets folder. Under that we have images folder and labels folder, and each this folder has train and val folder, under which we have images. Okay, and this classes.txt file, it's in root directory, you can say. You can see this, and it has a classes which we have used while we are labeling data. Okay, so that's pretty much what we have right now. Now let's go ahead and try to train our data set. Okay, so let's create new file in here, train data.py. Okay, sorry. All right. All right. So now in here, let's paste the code that we have copied. Again, you will find this code in a article. This code is pretty simple. Our aim is to use YOLO version 8 module, which is a trained module by YOLO, and it has trained on a huge data set. So this is a machine learning module which is already trained on huge data set. Now what our aim is so what we will do here is we will perform transfer learning. So images that we already have, images that we have collected, we will train that images on this already existing module. It's called transfer learning. So first we will load the module from the library that we have installed, which is Alterytics, and we will train our data set on that module. Okay, so you see here data.yml file which we have to create. That data.yml file will have path of images that we will have. So just start creating class.yml data.yml file. So let's go here, create a new file with name data.yml, YAML, sorry. Okay, and in here we'll have to put our file names. Okay, so in here we'll have to put this configurations. This you will get in article itself. We don't have to change this class names. So if you might have used different labels while labeling your data, you just have to update accordingly. And since we have only two classes, so we'll just put nc number to 2. This is really important. This is a link to your train and validation data set. So here we have folder name datasets under which we have all our data. So let's put it here, and that's pretty much it. We have the same folder structure in here. Okay, so now we are set, I guess. We can run this file and it will start creating module for us. So let me clear this. Let's reduce font size a little bit, and now here I'll put command python train data. Okay, let's see what happens. Okay, so first of all, it's gonna download yolo.pt file which you see here. So it's a module that is already trained on huge data set, and we will use this module to train our data. Okay, so I think we have some errors in here. Let's see what it is. Okay, so I think images folder is not found. Let's make sure that the path is correct. Okay, let's remove this dataset's name from here, and I think this should work now, because by default this YOLO module detects datasets folder, and under that it expects images and labels folder. So let's see if it works. Let's clear this, let's rerun this. All right, it has started training our module. You will see when it will start training your module, you will see one folder will get created in your working directory. It's called runs. Okay, and whenever you will run your train file, it will create new folder. So since we are running this second time, it created train 2 folder. Okay, now it will take some time to train our module. Since we have less data set, it should get completed within 1 minute, I guess. And it also depends on your machine performance and machine configurations. So let's wait until it gets completed, and hopefully everything, if everything work fine, we'll have module at the end. All right, it seems process is completed. Now you see here at the end, it will always give you folder name in which you can expect your end results. And these are some stats which I don't know what is it right now. You can explore yourself. All right, anyways, so let's go inside our train 2 folder, and here you will see a lot of different files. Few of the important stuff you might see is the stats that this training process um, provided you. So this is the results.png file, and this is what we have in here. I'm not sure what does this mean, but it will be interesting to see the meaning of this kind of stats, especially if you are working on improving the accuracy. So these are the stats that's going to be important. Let's see what we have. Train batch. Here you see these are the label data, and this is the process batch 0, I guess, and it has batch 92, batch 91. So this is some snapshot of training our data set, training our module. So you see here it has labeled as a 0. That means it is a mobile cover front, and you see the same thing in our class.txt file as well. So class.txt file, the first on the 0th index we have mobile cover front. On the first index we have class name mobile cover back. Now if you refer this, and let's go to this batch, this is mobile cover front, this is mobile cover back. That's why we have one on this label. So that means our training is kind of successful, but it depends on the end results obviously, but we have to test it obviously. So let's go to weights folder, which is inside the train 2 dot which is inside train 2 folder. We'll get weights folder, and in here you will see two different pt files. Now let me tell you, pt files is our final file, we can say, or final module, a train module file, which we will use to test our images. Okay, so this is the final output. You can share this with anyone, or maybe you can use this in your project to detect your objects. All right, so up to this point, if you're able to complete this process, first of all, congratulate yourself, because you have already completed the motto of this video, which is to create the first ever machine learning module. But now the thing is, we need to test this in order to see whether it is able to detect our images correctly. So we have to use any one of the image that we have used for the training purpose. Let's say this one, or you can use any image from the validation validation folder. Just copy it and put it in your root folder so that we can use this for testing. Now let's close this dataset folder entirely, and let's create new file. It's gonna be a test model.py file. Okay, so in this test model py file, we will use code to detect you know object from this image. Okay, so let's try to write code for this. The code you will get to detect module is from here. I just copy this. I'll walk you through the code. Okay, so let's see the flow of this code. It's pretty simple. Our aim is to use the module that we have trained, which is in our case inside the train 2 folder. If you remember, go to runs, train 2 folder, you will have weights, as I already mentioned. Under that you will see best.pt file. Okay, don't use last.pt file, you always use best.pt file. And then you have to load image that you want to test. So in our case, it's gonna be this file which we have just copied in our root directory. So let's paste it in here. Let me rename this. Copy here, paste it in here. Okay, then it will open this image. It will compare it with the module. Then it will show some results. If results is greater than 0, that means something is detected in that image. Otherwise it will show no object detected. So let's say if you have any random image, let's say dog image or a cat image, it's not trained, or that object is not there in this in that dog image, which means mobile cover is not there in that image. So in that case it will show no object detected response. And if we have mobile case in the image that we have provided for the testing purpose, if it detected, it will show, it will basically display image on screen, and it will highlight the label. Okay, and at the end, whatever the image that is created, it will be saved, so that you can refer it in future if you want. Okay, it has some dependencies. Just whenever you will whenever you will execute this code, you will get error if those dependencies are not already installed. Okay, so let's try to so now let's try to run the code. So test model.py. So since I already have dependencies installed, it might not ask me to install it again. Okay, now you see here, I have this mobile back label in here. You see, it has a probability or possibility of 0.43, which is 50% or less than 50%. So it's not confident, the model is not confident. We have to train this, we have to fine tune this module. Well, that's the next part. Maybe we can say this is something, a continuous process, I would say, because we might need to test our images, or we might need to train our module on different lighting condition, different zooming factor, also in a different surfaces. So there's a lot to work on, and we have to fine tune our algorithm, or maybe we might need to change some configurations. We might even need to use different process to train our module. We are currently using YOLO module, but if it's not giving accurate results, or results as per our expectations, we might need to switch to different libraries like TensorFlow. So there's a lot of work still remain, but at this stage we have a module which is detecting our customized images. But in your case, if it is not detecting it properly, and obviously it's not a good thing to test that image which we have used for the training purpose, because it's quite obvious that module is trained on that images and we are testing on the same data set. So always use image, maybe click fresh image and try to detect that image, try to use that image for the detection. But this is just a simple test. But now one more thing which I personally experienced is when I trained my module for the first time, it was not able to detect my images. And it is because the images that I've used for the training purpose, was the numbers were very less. If you see 7 or 10 images is not a good number, especially if you're training a machine learning module. uh, so what is the workaround for that? Okay, how you can increase your data set, that's what we are going to be covering in the next part. So here what you need to do is you need to augment your data set. Okay, in the layman phrase I can say augmentation is a process in which we use our existing images, which is this existing train data set or existing validation data set, and we perform some basic editing, you can say, on this image. Let's say you can rotate this image, you can zoom in, zoom out, scale up, scale down. You can perform such operations and you can increase your data set. Okay, so for example, this is the image. Our code will simply rotate this image horizontally, and we can create new image from that. We can zoom in a little bit, we can zoom out a little bit, and we will create two more images from that. So such a way, if we want to increase our database or increase our data set, we can do that. Okay, so let's try to augment a data set. So this is the code for that. Let's say Agument Dataset.py. Okay, here. Okay, let's try to understand what it is doing. First of all, it's gonna take existing paths. So this is the image directory, this is a label directory, and we have in let's say we want to augment our train data set. So let's mention train folder in here. Same with our labels, and this is the augmented directory which will get created automatically whenever we will execute this code. So currently we don't have this folder, and it will have multiple files compared to just 7 and 10 images. Okay, so let's see. Then this code is basically doing some randomization. As I mentioned, it can flip your images horizontally, it will flip vertically, then brightness change, some rotation, those type of things it will apply on the images, and then it will finally save that images. If you have time, you can refer this code. It's pretty simple and self-explanatory. If you have knowledge of libraries like augmentation, then you can certainly perform such operations on any images. Okay, this is a way basically to I'm not going too much in deep because that's going to be a boring part. Then there's a lot of technical aspects this code might require, and which I as a beginner, not the right person to explain each and everything. So you can explore it by yourself, or you can take help of ChatGPT to understand it. So if you run this file, so let's go ahead and quickly run this file. Let me show you side by side what are the changes you will see in this folder. So let me click on let's execute Agument Dataset .py. Now, if you observe, we will have augmented folder created. Under that, you will see images, that is under the train folder. You will see there's a lot of images created, and if you see, it has applied a lot of randomization. Okay, and it has increased our data set. Okay, these are the some gauss factor that they have applied, some blur. You see, you see this image is quite blurrish. So this is basically increasing this. Okay, so this process is basically helping us to increase our data set. Okay. Oh, cool. And at the same time, it will label images accordingly. So since even though this image is edited, but this is a mobile front image, so I don't know what's the name. It's a 59 AUG2. Let's try to find it. 59 AUG2 here. It should have a class 0 assigned, which is a mobile cover front class. It's a first index. That's why it has a 0 class name index, class name given. Okay, if there is any image which is a mobile back, so it should have one assigned, which is this in this case. Okay, so similarly, so this library, so this way is pretty cool if you have less number of images. Okay, so this is the augmentation process. Now once you have this augmented folder created, just go ahead and change your classes.txt file, sorry, not classes, data.yml file. So you just have to rename, you just have to put augmented in here, because augmented is the folder that is created, and under that you will have the same folder structure. Okay, we have to do the same augmentation for validation images as well. So let's go and do that first. So let's go to Agument Dataset, and then in here let's change it to val. Cool, and let's execute this again, and now you will see we have a val folder as well. Hopefully that's a quick process. Okay, it is completed. Now we have our complete data set ready, which is augmented. Okay, and now we have a better we have at least multiple images, at least 50 images to train our module on. So this will help to increase our accuracy. Now since we have a new data set, we have to train our module again. So just execute train command again. Now this time it will take a little bit more time because we have multiple images, so it might take around 10-15 minutes. and we will have um, test3 folder. I think it might have created by now. If you see in the runs, yeah, we have train3 folder, and at the end you will have base.pt file ready that you can simply use while testing your data. So this is a test module file. Just change this train2 to train3, and then use whatever the image file path that you have, and that way you will be able to test your newly trained um, module. For now I'll use train2 dataset again, and let's use this image, or maybe use some random image which has no mobile cover back. Now let's test our module on completely random image in which we don't have any mobile cover back or mobile cover front. So we have to copy its path and then go to your test module file and just change the file name in here. I'm going to use train2 because I can't wait until train3 augmented data module becomes ready. So I'm going to use train2 module itself. Let's see what it responds. So um, let's quickly execute python test module.py. I'm expecting it should give us response saying no object detected. Yeah, you see here we got no object detected, and here also there is no label given. Our module is working fine till now. It's successfully able to detect at least our mobile back and some random image. It passed those test cases. Now let's finally try a mobile cover front image as well, and let's see what we get, what output we get. So train test module, change the file name. Let's re-execute this. Cool. It able to detect mobile cover front. You see here it's almost 90% accuracy. So model is working pretty fine till now. Well, again I'm telling you, this is I have tested this with train data and validation data. Well, this is not the accurate way to test your module. Always collect new data. Maybe I might have to click new images and test our module on that images. I need to train our module on multiple images. Then I can expect some good accuracy. But for now, it is what it is. At least you know the process, how to train your first ever machine learning module, which was the objective of this video. I think that's pretty much it in this video. Thank you very much for watching. See you in the next video. Bye.